Hey everyone, welcome. I'll just give it another minute or so to allow a few more people to arrive and then we'll make a start. Okay, I'll make a start. Welcome to the second Cairo workshop for the Starknet Winter Hackathon. I'm just putting the links to today's notes and to the Slido session where you can ask questions and fill in the poll, etc. So we'll make a start. All right, hopefully you can see my screen now. All right, so that's a link to these notes. So please have a look at that. The workshops. So the first one we was more general. What we'll do today is look more in more detail at the Cairo language, uh, and more details about contracts and testing. And then in the final session, it will be a little bit more practical in the sense that we'll look at the types of things that you will want to be thinking about for the hackathon, common patterns and ideas around development for different types of applications. But today, here are the topics. We're going to start off looking at the language a little more. We'll look at some testing, some features about contracts. If we have time, I can just demonstrate a simple deployment that we had the details on this previous workshop, but I can go through and show you that. Also, we can have a quick look at Jedi Swap on the poll. That seemed to be the most popular of the tracks. So we can start to have a look at that and how you can interact with that from programmatically. So that may be something you want to do in with your project. Again, there's a Slido link as well. So please use that to ask questions as I'm going along. All right, so let's have a look at some more details about the Cairo language. Uh, just starting off with a couple of traits that you may have seen and wondered what they're about. If you remember from last time, we spoke about this idea that objects need to be moved or destroyed, and the simplest way that we can effectively indicate that something can be safely destroyed is to add the drop trait, and this is it's actually a no opt, so it doesn't really do anything as such. It's more of an indication to the compiler that it is okay to get rid of this object once it goes out of scope. So it's more there of as an indication, and it's the easiest way that you can pretty much that you can show that something can be destroyed. So here we have an example. If you didn't have this drop trait for the struct, then there would be an error in your main function. But if you add the drop, then you won't get an error once it goes out of scope. So that's what the drop trait is about. For more complex things, we have the destruct trait. For example, with dictionaries, there's a certain way that they need to be kind of deleted, I guess. They have to be what is called squashed. And so for that, we have this destruct trait. So you may well see this when if you have a dictionary and you're interacting with that, then you need to have that trait involved, and then you won't get an error when your dictionary goes out of scope. Okay, so those are some sort of similar ones. As a a real helper, I guess. There's this thing called a generate trait, because sometimes you will want to have a trait, um, and but you've already got the implementation, so you don't necessarily want to have to sort of write that separately. And so what you can use is this generate trait attribute, and then that will then the compiler will actually will create the trait for you. So you can see here we've got a struct, and we've got an implementation of some uh, two functions that we're going to use that are using this struct. And what we do is we just provide an implementation of a trait that we're specifying here. So we're saying we want this rectangle geometry trait, and then by using this generate trait attribute, that will be created for us. Um, because the compiler can work out that from the functions that we've implemented here, it obviously knows the signatures, so it can provide an implementation for us from that. Okay. Now, we'll move on now to something that is, if you're familiar with Rust, then you will have come across this. It's a very useful thing to know. It's a very well used part of the language, and it avoids a lot of boilerplate code that you might otherwise end up getting. You do see this in other languages as well, but yeah, it's very widely used in Rust and sort of Rust derivatives, and it involves a an enum called option, and the angle brackets here mean that this is we're using generic, so we can parameterize the type that is involved when we have this when we have an actual instance of this enum. Excuse me. And what it allows us to do is to indicate that either our something is effectively empty, or there's none of it, which is the non part of the enum here, or that we have something, in which case that something, the sum here, has the data type that we've specified when we're creating the enum. So that's the data type that we've parameterized by t. And why this is useful is that you can use this then as a data type as a parameter for functions, or as a return type from functions, and it will handle the case where maybe that function maybe has an error, or it just doesn't return a value. So rather than having to cope with the return type being two possibilities, what you can do is just return an option, and then within that you have those two possibilities. So it's a much neater way of handling return types from functions. And so we can see how this is used in a couple of examples here. And this shows ways where we're looking to find a value in an array, and in fact, in a snapshot from an array. So the first thing you need to remember is a little bit about snapshots and how to create those and return from those, do a dsnap to get values back from those. So just remember those two operators there. And then the code here is showing you two ways that we could find a value within an array. So we've got the first one, which is using recursion, and the second one, which is using iteration. So maybe I'll start with the second one, because this is perhaps is a little bit easier to understand. And perhaps I think people are more used to iterating rather than doing recursion. So here we have our function. We're passing in a snapshot to an array. The array is of a number of it's numerics, felt 252, and yeah, and then it's going to return a sorry, the value here is uh, um, the value that we're looking for, and it's going to return an option. So this is what I'm saying is the useful idea about options is often as a return value, because it's possible that either we will find the thing we're looking for in the array, or maybe we won't. So we want to be able to handle both of those possibilities. So so that's the function signature, and it is we start off by working out the length of the array. So that's going to be the bound for our loop. We initialize our index to be 0, and then we have a variable that we're going to do to show that the value has been found. So the or the value that has been found. So what we do initially is to say that it hasn't been found. So we set that up to be this none for the particular option. So this is the default value. If we go through and don't find anything, then this is what we're going to return. Effectively, we're saying we haven't found anything, so we have none value. And then we set up the loop here and go through, because we only have this one way of doing loops, we just have to loop around and then put in a way of breaking out of the loop and a way of reaching the end of the loop. So here we go through and we're using the index variable here to step through the array. We're making sure that we haven't gone past the end of the array by looking at the length here. Once we get to the end, then we're going to break out of this loop. Um, uh, oh, sorry, someone asking about the document link. Let me just share it again. Okay. Once we get to the end, we can break out of the loop. Otherwise, we're going to just add one to the index and go round and round. So then what we do here is we use this the asterisk here, the star, as our to desnap, so to get the value from this snapshot, and we check that against the value that we're searching for. So that is the item, the parameter that we passed into our function. So um, so if we have found it, if we found it in our array, then we set our found variable here to be sum. So this is the other possibility in the option. And what we do is with sum, you're wrapping around some extra data, and the data we wrap around here is the index. So we're saying that we're returning the index within the array where we found this value, and at that point we also break because we don't need to loop any further. Okay, and yeah, as I say, so we return from this function the found value. So either the only ways we're going to, or the only possibilities we have for found here are either we didn't find it, in which case we have option none, or we did find it in case we have option sum, and that sum is wrapping around a value which is the index where we found the thing we were looking for. Okay, so that's the way we do it with a loop. If we do it with recursion, we do it. Yeah, we obviously it's differently. We start off again. Uh, we're checking to see whether we've come to the end of our recursion, and if we have, then we're going to return none because that is, we haven't found it at that point. So that's the default value. The other thing we do then, at each time we're calling this function, we check then to see if the value for this particular index is the one we're looking for. If it is, then we found it, and so again we can return from this function with a sum value wrapping around the index. But if neither of those have happened, we're still going around, we're still recursing. So we want to go to the next step. So what we do is we call this function again, but in this case we add one to the index and call this function and keep going. So each time we're adding one to the index, we're stepping through our array, and then eventually we'll step through and our index will come to the end of the array, and that's when we'll return the non-value if we haven't already found the value up to that point. Okay, so you can see here our find value recursive. We have this index parameter, which is sort of showing or allowing us to take the next step in this recursion. Okay. So I think that's both of those fairly straightforward, but it shows you sort of how we use the options of none and of some to make our code simpler and easier to understand, easier to use. Now, an extension to this is the idea of matching. Again, we have a similar idea in Rust, so you may have come across this, but it allows us to write fairly concise code without a lot of sort of ifs and else. And this example here is showing, if you imagine we have this enum, which has these different possibilities, and we are going to pass a particular example of an enum into this function, and then look to see which of the possible values, the possibilities in that enum we have, and we do that by matching. So we pass a coin into our function, and then we match against that value, that variable coin that we've passed in, and within the match block here, we have these different what are called arms. And so it will match against the value we've passed in, and it will match against these patterns. So if it matches against the penny, then it will it will execute the statement that comes after the arrow. So what this effectively does is just return a one at this point. Or if it matches against nickel, then it will it will produce five, and so on. You can do more complex things within each one of these arms, execute more logic. But that's how matching works. It's a very powerful thing. And that's a very simple example. As I say, you can do more within a particular arm. So here we've got an example where if we match with penny, then we print out something more complex, but also return value as well. Now we can go further. We can bind values in as well. So you can see here we have the possibility for a certain one of these enums that we have an extra piece of data, this US state, and then you can see here within the match, if it matches, then that state is then filled in to this variable state that we have here, and we can then print that out. We also need to do some extra work with printing here to match on the particular value of state that we had as well. Okay, and then we can also uh, use our option when we're doing matching, and this is very common. So what we want to do here is we have a function called +1, and we're going to take in an option. This option is wrapping around values of data type U8, so small numeric values, and is going to return a similar option of the same data type. And then we're going to match upon the value, the type that we pass in. So we're passing our option in. It becomes this variable x, and we match against x, and we look and match against these different patterns. So if we have some within our option, then we'll do a certain thing. If we have none, then we'll do something different. So we'll look at the none option first. So if we match against none, then we just return none. So we're not doing anything, we're not adding anything to that because we don't have anything to add it to. But if we do have something, so in the option we're passing in, if our sum is wrapping around a particular value, then what we want to do is to add one to that value. So the way that we can add one to it is we can, in the option that we pass in here, when we're matching, we match, and we have this val here. This is a variable that we're introducing for this particular arm of the match, and it takes the amount that our sum is wrapping. So this x that has come into our function, this option the sum will be wrapping around a certain value, and we take that and create this variable val from that. So that then when we do our execution of this arm, what we do is we produce another sum here. So we're using option again and creating another sum. But in this in this case, what we do is we create that, we wrap that around the amount that we had in val, and we add one to that. So we are starting with some wrapping around a certain value, and then we're returning some wrapping around the value plus one. So what this matching is doing is really taking out the value that we had within our option and assigning it to this variable, and then manipulating that variable within this arm of the match statement. Okay. So this is quite powerful, and we can sort of we can use this as you can see here. In a If we call this from a function here, our main function, we can start off with our option being equal to sum and wrapping around the value 5, and then we can call our plus one function on that. So we pass this option into the plus one, and that takes the sum wrapping around the 5, and it adds one to that, and so this gives us the value 6 here. And if you print that out, it would well, you unwrap the value, but if you printed that out, then that would print out the number 6. The other thing we can try is to call this function with none, in which case it's going to come back with none. So it'll come back with the same thing. Okay. Now, when we're using matching, we have to make sure that we cover all the possibilities. Otherwise, it will tell us that we have an error. One way to help with that is to provide a kind of a default execution, and you can use this underscore operator to match any value. So this example here is a simple function where you're passing in some number. So it could be a very large number, but you're then matching against that and saying, if the number passed in was 0, then we're going to print out that you won. If the number you passed in was 1, then you print nothing happens. And then any other number that you pass in will print out this you lost. So this is the catch-all condition here that will catch any other value other than the ones that you've already got patterns for within your match. Okay. So I think that's quite straightforward, but yeah, give it a try. It's a very useful sort of keyword and way of a pattern encoding, and it produces quite idiomatic code. If you look at the way people write Rust, it's very commonly used, and it produces very nice and easy to read code. There are some limitations compared to Rust, so I've listed these out here. You'll find these if you try you try this in Cairo, and it doesn't like it, you'll get an error. So just to bear that in mind. Okay, structs. These are quite straightforward. They're just a way of creating larger items from simpler data types. I'm sure you've come across these in other languages. So you can see here we've got a bool, a felt 252, a U64, but we want to put those together to create a user object. And so the way we can do that is to create a struct from them. And then within a function, we can create an instance of that, as you can see here, with this type of syntax where you fill out the different fields here with values that you've passed in there. So that's the way. So you define the struct and then you create an instance of that. To get the fields from the struct, you can use the dot notation. Yeah, to do that. Now, within the struct, you cannot, because we have this possibility of mutability, we have to be consistent within the struct, whether it's all mutable or none of it is mutable. So you can't do mutability just at a particular field level. It has to apply to the struct as a whole. Now, when you're creating your struct, you can take some shortcuts. The compiler can work out which fields you're referring to, depending upon the variable name. So you don't have to make it quite so explicit here. It can work out that username refers to the username field and email refers to the email field, etc. So that's a little shortcut you can take. All right. Now let me just check that. Okay. So we often want to get a copy of a certain bit of data at a certain time, and this is what where we use snapshots. So this gives us an immutable view of some value at a certain time, and this helps with the issues around ownership and borrowing, etc. It's a nice, it's an easy way to do all of that safely. So here, for example, we've got a function where we're creating an array of U1 to 8 values. And what we want to do is to take a snapshot of that at this particular point. So we can use the snap operator to do that. And then you can carry on and do other things with your array. And that's not going to change your first snapshot. So that's kind of a record of what you've done, and you can then compare things as you can see there. Um, and this calculate length here is taking in a snapshot as uh, the the data type for the array. So it doesn't, when you call this, you don't have to worry about the function taking ownership of the array. It's just a snapshot that it's looking at. Okay. Now, so that's a little bit about language. Uh, I hope that all made sense. If you have questions, then please ask on Slido. Let's have a quick look at Scarb. I hope you were all able to get Scarb set up. If you missed that, then in the previous notes, there's details of how to install everything. I'll just quickly show you what you can do with Scarb. You can here create. You can use Scarb to create a new project, and you can see it gives you a default project here. Now this is a this is a this is not a contract. This is a Cairo program. So it is a little bit different, but this is we can still see Scarb used here. So I can do whoops. I don't. Uh, so you can see here, you can use Scarb test. It will compile our code. So you can see here, it's compiled the code ready for the test, and it has run the test, and the test has passed. So this is the test here. The test is in our lib file here. You're showing that it's a test with this attribute at the top here, and then so that's showing that this is our test module, and then within that we can have multiple tests at the moment you've only got one. So that's what that looks like. If that's a very simple way of doing it. If you want to do more complex tests, then typically you would put those in the tests folder. You would have your integration test typically in the test folder, because your tests here would be applying to a particular module. As you can see, for this one, it's a particular mod that we're doing or a particular program. So the unit test would probably live with the code, whereas with the integration test, they're going to apply to a number of things. So they're going to go into the test directory. Okay. Now that's using Scarb for testing, which is perfectly that will work perfectly well. Also, there's StarkNet Foundry. So StarkNet Foundry was created to do very fast testing and to add extra functionality, I guess. And so I put details in in workshop one's notes about the how to install uh, StarkNet Foundry. If you want to use it, there's some details here of how what you need to do to add to your Scarb project to do that. So you need to add this dependency here because the way that Foundry works is it will have some standard libraries that is using for to get to be able to do the testing. So you need to add this dependency into the TOML file. So this the scarb TOML, you would add this under the dependencies here. Okay, so that's the first thing you need to do. You also need to make sure that you're producing the assembly. So you need to put add this under the target here. So this, you'll see here, we don't have this target because this was a program rather than a contract. When we write a contract, you have this target of StarkNet contract, and then to integrate with Foundry, you will do this chasm equals true, and then to get Foundry to be to run when you're doing the tests, you add a script, you add something in scripts here where you're saying when you're uh, running test, that will call the Foundry test rather than the Scarp test. So that's the other thing you need to add to your configuration. Okay. All right. So that's that. Let's move on then to contract. So I just got this bit here is as to remind you of the layout of a contract. So we did cover this last time, so I'm not going to go through this really more. It's just to make this available. But there's some things we didn't cover. So today I'll talk more about components because we didn't talk about those, but we did talk about storage and constructors, etc., and all of these other pieces we spoke about. I've spoken about generate trait. Today. So that's what that is about. Yeah, and we spoke about we went through some example functions as well. So I hope you're all familiar with the sort of the basics of what a contract will look like. What we didn't look at last time, we didn't have time, were Open Zeppelin contracts. So I'll just talk about those quickly. So uh, if you haven't come across Open Zeppelin before, it's a project that provides uh, uh, example contracts in a number of languages, and they have some in Cairo as well. And these are provided as standard ways of solving particular issues, and it's very much recommended that you would use these. So they are written by people who obviously know how to write contracts well and make how to write efficient contracts. They will also have been very well tested, so you can be sure that the security of these is okay. And it really does make sense to use these contracts if they're available, rather than writing your own version. So they are solutions to some common things that you may want to do. But rather than writing your own, use Open Zeppelin contracts, and you can derive from them and you sort of add your own uh, uh, sort of details if you want, but it makes sense to start off with these. So you can see here we've got things like the ERC20 contract, the fungible token contract, and this provides the usual interface that you would expect, a little bit more than it does have some metadata as well, such as name, symbol, and decimals. It also does it in a different, so you have the camel case or the snake case possibilities there as well. So you can see here there's details of how you would if you wanted to use that. I think I've got this in the notes as well. But you can see um, you're using the the components. I'll talk about components in a second, but it's effectively using what Open Zeppelin have provided. Um, and you can then use this within your, rather than having to write your own storage, you can use the details of the storage from the Open Zeppelin contract. And similarly, with it will provide all the various functions as well that you would want to use. But as you can see here, you can customize this within the constructor by setting up the details of your own name and symbol for that particular token. So it makes much more sense to use something like this rather than having to write your own code for the if you wanted to create a fungible token. So have a look at that. Yeah, that's an example there. And if you're going to use the Open Zeppelin contracts, you will have to add those as a dependency into your config file, as you can see. So sorry, this is not formatted correctly, but yeah, you just add it as you can see there. But there's more details in the documentation as well. Okay. All right. So let's talk about components because we saw an example there, but I hadn't really gone through what they are. They're a relatively recent addition to Cairo contracts, and what they are designed for are to introduce more modularity and allow more reuse of code within contracts. So the components themselves are designed to be really small pieces of code or functionality or storage that can be reused amongst multiple contracts and that are sort of quite sort of standalone, in themselves. And they so they're not a full contract themselves. You can't sort of instantiate them or declare them or deploy them by themselves, but they are designed to be the building blocks of larger contracts. So what they can contain is storage variables, events, and functions. So once you've created a component with that, then you can use it, across multiple contracts. So it's a way of avoiding duplicating code and allowing code reuse. But as I say, you can't declare those or deploy them. Now, there's an example here. So let me make this slightly smaller so it'll be easier to read. So there's an example of a component here. So we'll just start at the component part here. So this is where we're declaring what our component is. So it's this component is using a function from StarkNet here. You can see, and then it's also this component is defining some storage. So our storage here has an address, this owner. And then we're defining a function here. And this function is then going to be allowed to be used in a contract that uses this component. And we talk about embedding this within another contract. And when we're doing that, we're saying it's going to be embedded with a certain name. So this is what the embeddable as, and then the ownable here. This attribute is saying that this next piece is going to be embedded within a contract, and when it is, then it will have this certain name. And then with the thing that we're embedding here, I mean, it looks quite complex. It's actually more sort of simple in what it does. So if we start from the inside, so we are creating a function. We're creating the implementation of a function. Oh, sorry, we're implementing a trait. So by with this function is called owner. It is taking in some a snapshot of some state. So it's a function that is not, it's effectively a view function. It's not trying to change state. So that's why we have the at here for to indicate that we're taking in a snapshot of contract state. And what it is going to return is an address. So in sort of higher level terms, what we're saying is we want to know who owns a particular contract, and this is going to return the address of the owner of this contract. And you can see that this function, the function body, what it does is it gets the value from its storage, this owner, and it reads that and then and returns that. So uh, that's the contract address that it's returning. Okay. The this implementation part here is a is saying we've got this ownable implementation. That's the trait. It's uh, it's slightly complex because of the generics here, but you don't worry about that so much. But that's just, so that we will get the right signature. And that is what we have at the top here when we're saying what is the interface from this is that iownable that we're actually trying to we're trying to implement further down here. Okay. So the thing uh, to take note of that is that we have this we have this attribute component. So we're telling the compiler that we're creating a component. We have this thing embeddable as, and we're providing a name with that. So that's how it's going to be known when it goes into a particular contract. Um, and then there's this plus has component here that is involved in the generics part here for our contract state. Okay. So that's that's defining our component. Now, when you're starting out, I guess you're probably not going to be defining components straight away. You're probably going to be using components rather than defining them. But later on, as you get more used to it, you'll probably then want to create your own components. But this next part here is going to be more useful for you initially, which is how you're going to be using a component within a contract. So here we've got a contract. So our ownable counter. So the attribute here is shown that it's a contract, and we're saying that we're importing here this particular ownable component that has been um, created, and then we're using this component macro to with that. So this the ABI here, this is showing our interfaces, how we interact. So we're saying that we're using the details from this component to for our well, the 2 points, the two choices we have for the internal part and then the external part here. So we're sort of pulling those parts from the component. The storage here, we have something of our own here. We've got a counter, but then we're saying we also have the storage from this component as well. So this is uh, the ownable part here. And then uh, we we can have because we when we created our component, we said how it was going to be embedded. So that's how we know we can write this as ownable for this particular function and call the owner function. And then we have our own particular function for our contract that we are adding within that. So we're just writing to we're increasing a counter here also when we call this foo function. Okay. So that's one example. You can see similar things here within the from Open Zeppelin, where you can see that they have ERC20 uh, components, which they are then using within a this, or we can use within our my token here. So rather than having to write all the sort of work out all the storage, etc. ourselves within our storage, we can introduce this component from the ERC20 component and have that here within our sub storage. Similarly, with the events and the component will have defined details of the implementations, and then the other thing we have is the thing we do ourselves here is the constructor, where we can customize this with our own details for the token. All right, so a little more complex, but yeah, you'll get the hang of that once you've been using contracts a little bit. There's details there about turning a contract into a component. I won't go through that, uh, but um, there's details there if you need that. And then this is again going through how you use a component in your contract. So use this component macro, which shows how to get the component and how it's going to be known within the contract. So details there. So you can have a look through that. Okay. All right. Something a little simpler is how you interact with other contracts. So we've had examples so far of very simple contracts, and we could declare these and deploy these. But what we will often want to do is then interact with another contract. And so in order to do that, we need to know details about the contract that we're interacting with. And so we need effectively the interface to that contract. And that interface is telling us what functions are available within that contract, what are those function signatures, as you can see here. Now, when we were interacting with that contract, we don't need to know anything about the internal functions because we can't see those, we can't interact with those. And similarly, we don't need to know about the constructor because we can't interact with that. The contract has already been deployed. We can't call the constructor. So all we're interested in are the other functions, the external functions. So you may see something like this. So for a particular contract, you could have this an interface like this. So, an example of an ERC20 interface where you're saying, so this contract is going to supply these particular functions. It's going to supply a name function, a symbol function, a decimals function, total supply function, balance of, allowance, and transfer from, and approve. So that's the functions that our contract is going to implement. But what this trait here, this interface is providing is just the function signatures. So this is just a guarantee that something that implements this trait will have implementations of these particular functions. And so if we have this, this tells us how we can then interact with a contract that implements this particular trait. So we know then that if we want to call the name function on this other contract, then this gives details of how we can do that. We know uh, the name of the function is called name, and we know the parameters. We have to sending a snapshot of the contract state, and we know that we'll get back a felt 252. Remember that we don't have native support for strings in Cairo. What we have instead is that string literals get converted into felt 252s, which is how we store them. So similarly, so that's has all the other details for all of the functions there. Okay. Now, you may well have come across this thing, the ABI, if you've worked with other languages such as Solidity. So what this gives us is a JSON representation of our contract. So it includes details such as the functions that are available within our contract and their signatures, etc. Um, and these are needed because if you want to interact with a contract, if you're writing a UI, for example, that's going to interact with the contract, you want to have this data about the contract. So you want to know what the functions are called and what the data types that you need as parameters, etc. So that's something that will be created for you. And then to actually interact with the contracts, we need this thing called the dispatcher, which will be created for us when you create an interface for the contract. So if we if you go back and the example we had was where our interface was called IERC20, which is this thing here. So we're saying that yeah, this is the interface to a contract that we're creating. Then when we actually compile that contract, then for us, we'll get created a contract dispatcher and the library dispatcher, as you can see here. And this, we also get this trait, which we can use then to uh, to call those. So the way that we could use these. So if you imagine we've got our IERC20 interface and we've used that and we've implemented that in a contract and compiled that and got our dispatchers, etc. Then um, then in another contract we would have the interface detailed and then within our this other contract we're creating this contract called token wrapper and then we can import these dispatchers that have been created for us and um, the rest of our, we're not doing very much in the rest of our contract, but then we have particular functions here where what we're doing is we're wrapping around the functions that we have in our IERC20 contract. So within this contract, this token wrapper contract, we're creating a function token name which is going to take in a snapshot of the state and a contract address and return a felt 252. So the equivalent of a string literal. So the way it does that is that it wraps around the function in the contract that we're calling. So what we do, rather than getting the name from this contract, this token wrapper contract, we get the name from the contract whose address we've passed in to this function. So this function here takes in our contract state, but then it also takes in this contract address. So this is the address of the contract that we want to get the name of. And so the way we do that is we use our dispatcher here, and we do use that contract address and then call the name function upon that. Um, uh, yeah, and that's how we can do that. And similarly, we can do that similar thing with transfer token, where we do the dispatcher around the transfer for that. So this token wrapper contract is just simply when it gets a call to provide a name or do a transfer, it just dispatches that and gets another contract to do that for it. So as you can see, by using this dispatcher that we've got here, this IERC20 dispatcher. Okay. All right. How are we doing for time? Okay, we've got time. That's a few details about um, a few more details about contracts for you. Um, Now, talking about testing, we spoke about testing with Scarp, uh, but we were just looking at a program then. And then we said about using StarkNet Foundry as well. If we want to test contracts with StarkNet Foundry, we do a similar thing. So we have to add in the standard libraries for StarkNet Foundry into our dependencies of our TOML file. So you would add that here within your TOML file. Um, so if you yeah if we take this whoops uh, sorry I skipped out of the document. Let me go back. Um, Sorry about that. So if we have this, say we have this contract. So we've created this contract and we want to be able to test it. So this first part here is the interface to our contract. So this is defining the trait that this contract is implementing. So what we're saying is within our contract, we're going to implement two functions. We're going to implement an increase balance function and a get balance function. The get balance function is a view function. You can tell that by the fact that we're passing in a snapshot to the state here. And this get balance function returns a number, a felt 252. The other function we have is the increase balance function. This is going to change the state, and that's why we have the ref here. And so this takes in the contract state, and we're going to mutate that, and it also takes in an amount that we're going to by which we're going to increase the balance. So we're going to add this amount to our balance, and that's of a numeric type again, and it doesn't return any value from that. So that's the interface to our contract, and this is the actual contract. So we've got some storage. So it's very simple. It's just one variable called balance. It's a number, I felt 252. Um, and then saying here we're showing our implementation. So this I hello StarkNet is our trait that we are implementing. So this is we're saying here we're implementing this of that particular trait, which is parameterized by contract state. So because we need to pass in the contract state. And then this part here is where we write we write the implementations of these functions that we've defined in the trait. So the first one, the increase balance, as I say, we're passing in the ref here to the contract state. And then what we do is we uh, use our balance that we've got in the storage. So we do self.balance because the self is referring to the contract state. And then we can write to that by using the .write method on our balance. And what we write to is the existing balance. So we read the balance and then we add to that the amount. So I think I had an example of this in the previous workshop. So it's quite straightforward, I think. But that's our implementation of the increase balance function. Okay. So to get the balance, we have the get balance function. This is the view function, so we have a snapshot to the contract state. We're returning a number, and again, we go to our storage and do get the balance variable from the storage, and then do read, and that returns the balance that we have. As you can see, this is quite a simple thing in that we just have one balance. We don't have, it's not more sophisticated than that. Um, so when we are getting the balance, we're not passing in any other value. We're just passing in the uh, the the state of our contract, the snapshot of the state, as you can see there. Okay, so that's our contract. So quite a simple contract. It only has two functions that we have. I don't think we had a constructor, did we? No. So it is quite simple. But then if you wanted to write a test for that, this would be how you can do this. So um, you you first of all have to say that you have to import the standard libraries for Foundry, as you can see there, and then you use the test attribute to show that this next function is a test and will get called as a test when you invoke your test runner. So what because it's a contract, there's much more that we need to do. If it's a program, it's quite simple. We can just run that. But a contract obviously is more complex because it needs to be declared, needs to be deployed. Yeah, it's a much more complex thing that we have to do. So uh, you can see here, first of all, uh, we declare the contract. So we've had that. Hopefully, yeah, we call this Hello Starknet, our contract. Yeah, there you go. Hello Starknet is our contract. So we're doing the declare here, which, if you remember from the previous workshop, that's the first step we have when we're wanting to deploy a contract. You first of all you declare the contract, which is setting up creating a kind of a class, a kind of a blueprint of the contract, and making that available. And then once you have that, then you can deploy the contract. And so then you get a particular instance of that contract. When you declare the contract, that's just really a blueprint of it. It's not something that could be invoked. You have to actually you have to deploy an instance of that contract to actually invoke it. So yeah, so in our test, first of all, we declare our contract, as you can see there. Once we have that, then we can deploy that, and that will bring back an address. And we pass in an array there for the um, uh, that will be for use for the constructor. Um, and then once we have that deployed, then we need to be able to interact with that. So we've deployed our contract, but obviously in our test, we that's just the setup really. We want to be able to interact with that contract to test it. So to do that, then we need a dispatcher. So we create one of those from the dispatcher that will have been created for this particular contract. Because when we created our contract, we created an interface, and so the compiler will have created a dispatcher for us. Whoops. So we can then get that, but we need uh, to pass into that the contract address that we got when we deployed the contract. So after all of that, then we are ready to actually do a test. So there's a lot of sort of legwork initially before you can sort of really test this. But at this point, we can then start to test it. So we can then use that dispatcher to call a function within our contract. So this get balance function, this will then get called on the contract that we deployed, and we'll bring back a number, which is we're going to put into this variable called balance, and then we do the assertion part of our test, and say that we're asserting that the balance is 0. at that point. And then we we want to sort of carry on with our test and test the next function. So here we again use the dispatcher. This is really the handle that we have for our contract. And we call the other function within our contract the increase balance, and we pass in an amount. So we're going to add 100 to our balance. So we do that. And then we want to check that that worked. So we use the dispatcher again and call again our get balance function, and that returns a value balance. And then we do the assertion here and check that the balance that we got back is in fact the original amount plus 100. So you can see that that there. Okay, so that's a way to do quite a simple test, but using Foundry there from a simple contract. Okay, right. So a drink of water. Okay. All right. Now, what I thought would be useful before I go on to the final part where we're looking at Jedi Swap, I thought it would be useful just to um, go through the um, an example. So the example I gave yesterday, I could just walk through that just so that we see that in action. Of course, I do appreciate that it's likely to uh, demos tend to go wrong. So apologies in advance if this doesn't work, but I'll keep my fingers crossed. So I think let me just check the notes from not yesterday, but last time. The idea was that yeah. So please have a look at the. In fact, let me get the previous notes here. Um, uh, so yeah, we had the where were we? We went through lots of stuff. Yeah. Uh, okay, so this was what we were going through. So I want to. I think it's worthwhile us walking through this because we've got a bit of time. So I've already done the very first part here, the new Hello World, as you can see. But what that gave us wasn't a contract. It gives us a Fibonacci here. Uh, you can, just in case you're thinking that this doesn't actually, you can check the test. I mean, you can make it a failing test here. No, I showed that. Yeah, there you go. So you can see what happens if it fails. But yeah, we're not really worried about that. So that's the default code that you'll get with Scarb, but we don't want to use that. Whoops, wrong one. Let me move this over. Uh, what we want to do is well, first of all, change our the package here to our TOML file uh, to be different, so to get the dependencies, etc. So we've still got the same name. Now we've got a dependency on StarkNet, and we're saying that we're trying to build a contract rather than a program. Okay. So, but we don't have the contract yet. So what I want to do next is get that code for the contract. So I put this in a gist so you can also do this relatively easily. And I'm going to call, I think it was called contract. Cairo. So that goes in there. Sorry, the syntax highlighting is not perfect, but that's that. And then I change the whoops. I change the lib file that we have there, our lib Cairo, and oops, let me find. Oh, okay. It's uh, going to be a little bit awkward. All right. Oops. So, yeah, that's what that should be. So that should be all of that. So what I should be able to do now is a scarp build. So now I want to build this. Okay, so it's built um it's built this and uh hopefully that's no it hasn't. Okay. Let me get rid of this. Try again. Um oh, hold on, I've changed. Okay, I changed the wrong thing. Uh sorry. Uh, um, okay. Uh, so that's that one. Let me close that. That's that one. Okay. I'll try again. If this is not going to work, then I may well just give up. Let's see what that's going to. Okay, that's better. So that's given us that's built it out as a contract now, which is what we wanted. Okay. Um, Yeah, so that's we've got our files. So I can take you through the details of declaring this and deploying it. So you have to follow these details. I don't think I've done this for this particular uh, project, so I'll need to do that. So let me try that. So again, you need to get the Starkly uh, installed if you don't have that. Okay, looks like I have. Okay, so this is setting up this is set up a key store, so you can see there. It's giving me a public key. Now you have to remember with this that the public key is not the same as the address that you're going to be using because we have account abstraction. So there is a kind of another layer that is involved. But that is setting up my key store anyway. That was the first one. Then I need to then set up the account um, like this. Uh, okay. Um, So that will have that will have declared the account and it's given me an address for that. But I need to uh, deploy that. So I run the third thing here. Okay. Whoops. I think I mistyped. Okay. Now, so what it has given me is it's given me the address that I'm going to use, but it needs um, funding. So what I need to do is to go to the faucet and fund that address. I hope. Oh dear, we could be here a while. Um, uh, okay, so apologies about this. Please, I never know how to. I must be a robot because I'm never sure how to fill these things in properly. Um, yeah, talk amongst yourselves, or skip forward on the video here while I try and get past this. Um, there's a bicycle. Have we got all the bicycles? I think we have, as I can see. Okay. So, yeah, you need to go to the faucet anyway and ask for some test ETH for this. So that's what I'm doing. At the Galley faucet. Okay. Um, once this, I'm hoping this is not going to take too long. Otherwise, yeah, we're going to run out of time. Okay, so that has sent some test ETH. So I can now carry on, and that has then tried to deploy it. It's given me a transaction hash, so we can have a look at that with Voyager. So here we go. Here's my transaction. It just shows what I've just done. So that, whoops, yeah. So that was all doing this. Is all getting my account set up. Um, so that's the account abstraction part. Now, what I want. So now that I have my account set up, I can then use this contract. So the next thing to do with Starkly is this thing here. I hope I've got this tends to. I did have problems with this um, before, but let's try this out. I hope this is going to work. Uh, oh, okay. Where am I? Uh, maybe I've got a. Oh, okay, I've got the wrong name for this. So yeah, you have to get the name right. So what we've got hello starknet dot. Yeah, sorry about this. Okay, try again. Okay. I'm also making some typos. Oh, yeah, I can see. I needed a sort of hello world in front of that. Oops, sorry. Uh, if this doesn't work out, I think I'll give up and just carry on. But you can see the general procedure you have to go through. So it is a bit fiddly. Okay, I'm going to give up at that point. But that's the you need to go through. You need to declare it. Once you've done that, it will bring back a hash, which you can then deploy it, and then that will become available on the test network. Okay. All right. So yeah. So that's that. Let us go on then. To finish off, we'll just have a quick look at Jedi Swap because. I we had the poll where I asked people what they were interested in. Certainly, if you haven't filled in the poll on Slido, please do that. But it looked like Jedi Swap was coming top of that poll for this listed out the tracks that are available in the hackathon. It looked like Jedi Swap was the most popular one, so we can have a look at that. So. Uh, this is the website. The you can have a look at the app. So it provides, this is showing a very simple swap functionality. So I don't know, maybe I want to swap DAI for USDC. You need to connect a wallet and then you can do your swap. I'm guessing here, yeah, it allows me to specify slippage tolerance and a deadline for my transaction as well. So that I hope you're all familiar generally with the idea of what an AMM or a DEX does, and generally how AMMs work. The idea that we have a pool of a couple of tokens, and we're swapping between those. The important things from that actually are on this part, the tolerance. So this means if I filled in some values here, maybe I would get back I don't know, 2000 USDC. And the slippage tolerance is saying, well, that's the amount I'm expecting, but how much variance from that would I be willing to accept? Because in the time it takes for my transaction to actually complete, it could be that the price will change. So this is the idea of the slippage tolerance. And then also we have the transaction deadline, where this means that your transaction could spend a long time waiting to be executed. And if that's the case, how long would make sense for you? I mean, it could be that after 5 minutes, you wouldn't want your transaction to go through because your the situations would have changed too much. So that's the other option that you get there. So that's if you're interacting via the UI. But what's probably going to be more useful for you is to interact programmatically. And so there's some details in the technical documentation here about implementing a swap. So how to interact with the actual contract to implement a swap. And this is a way that you can do some composability. So you could get your contract to then call this contract and do a swap, and then maybe that would, you would get the results back from that and go on and do something else. So the details of that are given in this documentation here. So this is the smart contract integration part. And so this goes through this. I would say it's quite standard in the way that this works, in that you have this concept of a router contract, which is a way that DEXs provide. They provide a common sort of interface or a common entry point for interaction with when you're doing something like a swap. And so you will interact with that router contract, and then you will be telling that details of the type of swap that you want to do. So you'll be telling it details of the contract, the pool that you want to interact with. So the pair of tokens that you want to interact with. You'll be telling it the amount that you want to swap, and also the slippage and the deadline that you want. So yeah, so it's the router contract you would need to interact with. There's details here of, excuse me, how you would do that. So what you need to do, first of all, is fund this, to send some funds to the contract, because these are going to be the tokens that you want to swap. So you need to send these so that the router contract can then use those to do the actual swap. So this here is the way that you can do that. So this is giving an example of using uh, using DAI, the DAI token you're going to transfer. And so it's saying it's sending this off to the router contract. Sorry, this is to your contract. Then you need to then to approve the router contract to withdraw that. Sorry. So once you've got some DAI, you approve the router contract for that. So this is going to allow the router contract to spend those tokens on your behalf. So this all of this is quite common to many different DEXs. They tend to take a common approach to doing this. And then once you've got that set up, what you need to do then is to work out the actual swap that you want to do. And this is the details here. So what we're starting off with is uh, getting we start off with this idea of the deadline. So this is because we want to put a time limit on how long our swap is valid for. So that's why we're getting the timestamp. We need to get some details here from the local path that we're going to then use in this next part. And then we then fill in. What we do then is to call this particular function where we're doing a swap exact token for tokens. Now, there are different ways that you can do a swap. So you can swap exact amounts for so you can provide an amount that you want to swap and then say, well, I would accept back any amount of tokens. Or you could say you provide an exact amount, you're only going to accept back an exact amount back. Or maybe you would say, well, I want to get a certain amount back. And then you would provide, you want to know how much do I need to provide to get that amount back. So there are different options that you have. But this one is saying we're going to swap, we're providing an exact amount and we're going to get back a certain number. And we're providing the details of that. Now, so this is saying we're providing details of the router contract. We're providing details of the amount that we want to swap. And then we say this amount in minimum. This is really the specification of the slippage that I spoke about. So this is saying this is the minimum amount of tokens that we would where it's acceptable for us to get back. And then we've got the details of about the path for the particular tokens, and then we pass in also the where the tokens are going to where the tokens shall come back to, and then we pass in the deadline as well that we've worked out. So that is those are the types of details you need if you're interacting with an AMM, and it's fairly similar for all different types of AMMs. Okay, we're pretty much out of time. There's more details here, so you've got links there about that, so you can have a look. We can look at this in more detail in the final session if people are interested in that. Okay, so I'm going to stop there. I'm sorry my demo didn't work, but I think it's valid. I think I just had some typos in there somewhere, but you can work through that yourself. If you do have problems, then you can either ask questions on Slido or ask questions on Discord as well, and we can pick those up in the next session. All right, so thanks everyone for attending today. I'm going to stop sharing now. Uh, there will be recordings. So I think you've got details of those in the chat. So yeah, thank you for attending, and I look forward to yeah. Let me just quickly link to the document again. So there you go. That's a link to the document. Yeah. So thanks for attending. And I look forward to seeing you all on Thursday for our final session. Thanks, everyone, and I'll see you later. Thank you. Bye-bye.